Today, we're going to look at polar coordinates. So in most of our mathematical career, or all of our mathematical career, we've been just dealing with our rectangular coordinate system. And so we would look at a point, X, Y, and from that point, we could plot it. Polar coordinates is a different way that we can get to a point. So this is actually a great review of what we were doing at the beginning of the semester. So let's first look at a point. Maybe let's say 1, 1. So our X value is 1, our Y value is 1. So let's plot that point on our Cartesian plane. So we have our X axis and our Y axis. And we have some point up here. And let's evaluate our 3 trigonometric functions, cosine, sine, and tangent of theta at this point 1, 1. And so in the past, at the beginning of the semester, we looked at making a triangle. So let's make a triangle with this point. So we have this right triangle. We have our angle theta in here. We know what our X value is. Our X value is 1. Our Y value is 1. And we can figure out what the hypotenuse is. So for polar coordinates, that hypotenuse, or that length here of the terminal side of our angle, we're going to call is R. So we know how to find that hypotenuse. We know that R squared by the Pythagorean theorem is equal to 1 squared plus 1 squared. So we know R is equal to the square root of 1 plus 1, which is 2. So we can find our trigonometric functions knowing the ratio of sides of the right triangle. We know here that cosine of theta is equal to the adjacent, which is 1, over the hypotenuse, which is, or R, which is root 2. So rationalizing our denominator, we know that cosine theta is equal to root 2 over 2. Similarly, we can find sine theta. Sine theta, we know is opposite over hypotenuse, or R, which in this case, opposite of our angle theta is 1. R is root 2. Rationalizing our denominator, multiplying by that fancy 1 of root 2 over root 2, we get root 2 over 2. Tangent theta we know is opposite over adjacent, 1 over 1, which is 1. So we were able to find our 3 trigonometric functions. Let's say that we wanted to figure out what our angle theta is. Well, we can use the ratio of our sines. Let's use what we were given, opposite and adjacent. So we know with opposite and adjacent that we can find theta by looking at the tangent inverse. So we know, again, tangent theta is 1 over 1. We could take the tangent inverse of both sides of our equation. So tangent inverse of tangent theta, that's equal to theta, is equal to tangent inverse of 1. So theta is equal to tangent inverse of 1. So we think backwards, we think to ourselves, okay, what value of theta would give us tangent equal to 1? And that is when theta is equal to 45 degrees. Or theta is equal to radians pi force. So there's another way that we can get to the same point here on the rectangular coordinate 1, 1. And that is by using polar coordinates. So polar coordinates, these are in the form of the first number you'll see is R. R is this length here. And the second comma second number that you'll see is the angle theta. So in this case, we could have gotten to the same point by looking at what is theta. In our case, we just found that theta was pi force. So that's our second number. And what is r? R we found was √2. And so the polar coordinate that would get us to the same place as the rectangular coordinate 1, 1 is √2, comma, pi force. So let's look at this as a generic case. So let's say we have this point x, y. And I'm just going to put it into the first quadrant, but you do need to be aware of what quadrant you're in. So let's say that this is x in here. Let's say that this is y right here. We have some point here at xy. So again, we can make our triangle here. This is angle theta. We know that this length down here is x. This length over here is y. And we know that we can find r by the Pythagorean theorem. So we know that r squared is equal to x squared plus y squared, or r is equal to the square root of x squared plus y squared. So we know we can find that r value of our polar coordinate by looking at the square root of x squared plus y squared. Theta, like we had done above, we can find theta. This is equal to the tangent inverse of opposite over adjacent. So our opposite side of our angle theta is y over adjacent, which is x. So given this information, we can convert between a point, which is in the rectangular coordinates, into a point which is on the polar coordinate. So let's look at a couple of points first before we start converting back and forth. Let's look at a couple of points that are given to us in polar coordinates and look at graphing those. So let's say, for example, we have the point here. R is 3 and theta, let's say, is pi 6. So what we're going to do, so the polar coordinate system looks a little different than our rectangular coordinate system. Basically, where our origin was for the rectangular coordinate system, that is called the pole. There's this point here called the pole. And then extending out towards the positive x direction, this is called our polar axis. So just like we were doing with angles before, if our angle is positive, we're going to go counterclockwise. And so we're going to go counterclockwise here, pi 6. And then we'll get to our terminal side. So going counterclockwise, pi 6 in here. We have our terminal side of our angle in here. And so now we want to go out on this terminal side 3 units. And so a lot of times you'll see these circles in here. So the unit circle and a circle here, radius 2, a circle here, radius 3. It's not great, but you can see what I'm doing. So we're going to count our way up 3 of these circles at pi 6. And that is where our point is going to be of 3 pi 6. So we could just look at our R value here, our terminal side, and go up 3 units. And so this point right here is going to be that 3 pi 6. But recall when we were having a terminal side of an angle, there was multiple ways to get to that terminal side. Remember, we could add 2 pi to our angle, and that would do a full revolution back to that terminal side. And so there's an infinite number of ways that we can get to this polar coordinate of 3 pi 6. And so you should be able to find other points that and polar coordinates that would get us to the same point. So for instance, like we just said, we could add 2 pi to pi 6, and that would get us to the same spot. And so an equivalent point to 3 pi 6 is 3 pi 6 plus 2 pi, or technically we could add some multiple of 2 pi. So 2 pi times k, where k is an integer. Remember that funky letter Z meant integers. So integers are the numbers coming in from negative infinity, dot, 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 -3, -2, -1, 0, 1, 2, 3, 4, dot, 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 going to infinity in that pattern. So there is an infinite number of values right there that would get us to the same point of 3 pi 6. Our R value can technically be negative. And I'd actually, before I do that, let's actually list a point. So let's just, as you might be asked to, list a couple points. So if I was adding 2 pi to pi 6, let me just do that down here. We would need a common denominator. I could multiply that 2 pi by 6 over 6, fancy one. And we get pi 6 plus 12 pi 6. Well, pi 6 plus 12 pi 6 is 13 pi 6. So here's one point that's equivalent. So what I was just about to mention to say is that if our value R is negative, you're going to sweep out going to the terminal side of your angle that you were given. So let's say in this case, let's say it wanted us to graph or plot the point -3 pi 6. So instead, this time our value is negative for R. So we're going to go pi 6 from our polar axis. We're going to go counterclockwise pi 6. We get our terminal side here. And instead of counting up 3 spaces from our terminal side, we're going to go in the opposite direction. So let's extend our terminal angle. Right here. And so now we're going to go down on that terminal side 3. And so here, this point right here, this is the point -3 pi 6. So to get another point that's equivalent to our 3 pi 6, we could have done the following. We could have swept out the angle that gets us to this terminal side. And so that would be pi plus a reference angle of pi 6. So that angle in here, theta, So pi plus pi 6, that is 7 pi 6. And if we looked at 7 pi 6 and we wanted to get back up here at 3 pi 6, we could say we're going to go 7 pi 6. So that's our second number. But we want it to be in the first quadrant and not in that third quadrant. And so we're going to look at that as being -3 here. So again, there's an infinite way that we could get to the same point for our polar coordinate. So let's look at plotting a couple more of these points. Now that we know some of that terminology and we know what to do when we have a negative value for R. So we have an example in front of us. It says plot each point given in polar coordinates and find other polar coordinates R theta for which A, R is greater than 0 and theta is between -2 pi and 0. B, R is less than 0 and our theta is between 0 and 2 pi. And C, R is greater than 0 and 2 pi is less than theta is less than or equal to 4 pi. So our first example, we have our polar coordinate 4, 3 pi force. So I inserted in here what a polar graph would look like, and you can get that off the internet if you'd like, or you can just kind of create it yourself like I was doing above and the other examples. Okay, so first example, again, we have 4, 3 pi force. So I need to go to my polar axis. My angle is positive, and so I'm going counterclockwise, and I'm going counterclockwise 3 pi force. And I'm going up. R is 4. So counting 4 the circles. So I have 1 here, 2, 3, 4. So this right there is our point for 3 pi force. And I use the angle and stuff just to help me to get there. There we go. Okay, so part A of this question wanted us to, after we plotted it, wanted us to find a similar angle though, that R is positive. So we know our R value in this case is 4, positive, but our angle is negative between -2 pi and 0. So we need to start at our polar axis negative. So we're going clockwise to this position right here. So I know my reference angle, if I was looking at this, is pi force. And so I have negative pi minus pi force. And so that's going to give me -5 pi force. So that answers question A. Now we want a value of R, which is less than 0, and our angle is between 0 and 2 pi. So if our angle is less than 0, not our angle, our R value is less than 0, let's look at our terminal side. We want to extend that past the pole. And so we want our angle to sweep past the terminal side to the opposite direction of our terminal side. And so let's think about that and how much theta has to be. Well, we're going basically, again, my reference angle is pi force, but I'm in the 4th quadrant. So we can think of 2 pi minus pi force, or 8 pi force minus pi force, which is going to give us 7 pi force. So there, my angle is 7 pi force. But I don't want to be in the 4th quadrant. I want to be in the 2nd quadrant. And so I can get from that 2nd quadrant by making my R value negative. So -4, 7 pi fourths would be our polar coordinates with those stipulations. And then the last part, C, said let's find r greater than 0, and our angle theta is between 2 pi and 4 pi. So if r is positive, well, we're going to keep it 4. But we are going to need to do 1 full revolution, that's 2 pi, and then plus our 3 pi fourths. So 2 pi, let me just write it up here, plus 3 pi fourths would get us to that same terminal side, common denominator. So that's 8 pi fourths plus 3 pi fourths is 11 pi fourths. Okay, so we were able to plot our polar coordinate and find 3 polar coordinates that were equivalent, would give us that same point. So number 2 wants us to graph -2, 3 pi. So starting at our polar axis, we're going to go 3 pi. And so I know that's more than 2 pi, so I have a full revolution plus a pi. So this is going to get me to what would have been our negative x-axis here. And so that is 3 pi. The negative x-axis though, but my r value is negative. So I want to go in the opposite direction. And so I'm going to go in the opposite direction, which will look like on our polar axis, or what I think of as our positive x values, x-axis. And so we're going to go over 2. So 1, 2. So this would be that point there, -2, 3 pi. So now finding part A where r is greater than 0. So I know my value in here needs to be 2. And my angle is between between -2 pi and 0. Well, to get to here, and it's including 0, but not 2 pi. And so to get to here, I'm going 0 radians or 0 degrees. Part B says that r is less than 0. So we have -2. Oops. And our angle is between 0, including 0 and 2 pi. So -0 and 2 pi. So I need to get here, that point. My r value is negative, so I'm going to go pi. So that would sweep her over here. That would give me this terminal side going in the opposite direction across the pole. 2 gives me that point. And the last one, C, we want r greater than 0. So we want it to be 2. And our value is between 2 pi and 4 pi. Not including 2 pi, but including 4 pi. So I know I need to do 2 full revolutions around to get me back over here to that terminal side of that point. And so my angle would be 4 pi. Okay, so let's look at a couple of more examples, just plotting the points really quickly. I'm not going to go through and find equivalent points just to save some time, but looking at the following, let's say we had -3 and negative pi fourths. So I want to first go pi fourths from my polar axis, which would get me here. And because my r value is negative, so going across the pole on that line and going then in the second quadrant up 3. So 1, 2, 3. Give me this point right here. My next problem is -2, -2 pi thirds. And so I do my angle first. So I'm going to -2 pi thirds. I'm going clockwise. And so that's going to get me into this third quadrant. Okay. And so looking at this, and I think that they actually have these lines in here for special angles. So let's just use them. So maybe I'm just gonna estimate it. Let's just say it's here. And then we're going to go in the opposite direction across the pole and go up 2 circles. So doing that, going up 2 circles. So we are right here. Okay, so that was our point, -2 pi thirds. So we should be able to go from rectangular coordinates to polar coordinates and vice versa. And so we had just saw, or I was saying before when we had started this, that if we have a point X, Y, we can figure out what R is. R is equal to the square root of X squared plus Y squared underneath the radical. Theta is equal to tangent inverse of opposite, so Y over X. We do need to put a stipulation here that X cannot equal 0. Okay, so let's look at converting a couple. Excuse me. Let's look at converting a couple of these from rectangular to polar coordinates. So here we have a point -3, 3. So we can just throw it into a formula, but I think just knowing what you're doing and not having to memorize this formula and not understand what you're doing, I would graph this. So our X value is -3 and our Y value is +3. So we have this point right here, -3, 3. Again, we can make a triangle. We always use that base of the triangle, the x-axis, never the y-axis. And so we need to figure out what theta is. We know what X and Y are. We know our X value is -3. We know our Y value is +3. And we need to figure out what R is. So let's look at what R is. R is equal to the square root of 3 squared plus -3 squared. So R is equal to the square root of 9 plus 9, which is 18. I would probably pull out any factors underneath the radical that are a perfect square. I know square root of 18, well, 18 is 9 times 2. So square root of 9 is 3. And then the 2 is left underneath the radical. So we figured out what R is. Now we want to figure out what theta is. So theta in here, we know we can use tangent inverse. So tangent inverse, theta is equal to tangent inverse of opposite, which is 3, over adjacent, which is -3. So theta is equal to tangent inverse of -1. So we just need to be careful and we need to think about what quadrant we're in. So tangent inverse, our value is between -π12 and π12. I know that π4, tangent of π4 gives me 1. So I know my reference angle is going to be π4, but I want to be over here in that second quadrant. And so my angle theta is pi inside the rectangle theta sub r, let's call it the reference angle in there, is π4. So I need to figure out what angle is going from that polar axis to that terminal side, that the r value. And so pi minus π4 is going to give me 3 π4. So theta is equal to 3 π4 here. And so we just figured out what the polar coordinate was. It would be 3√2, comma 3 π4. Again, as we just saw in the previous examples, there's an infinite number of ways that we could get to that same point, -3, 3, using polar coordinates. Let's look at one more. So let's say that you have, how about -2 and -2√3. X value is -2, our Y value is -2√3. Okay, so let's plot it so we know what quadrant we're in. So X and Y are both negative, so I know I'm in quadrant 4. I'm going to go over to left -2, and I'm going to go down -2√3. And so let's just estimate. So -2, -2√3. So doing that, -2√3 is about -3.5. So we'll be about right here. So let's create our triangle. So we want to figure out what theta is. What would get us to this terminal side. So when we look at this, we are really going to be getting that angle in here. That is our reference angle, where our reference angle is contained in quadrant 3. So we know we can figure out what R is by using the Pythagorean theorem. And so R is equal to the square root of -2 quantity squared plus -2 times √3, that quantity squared. Order of operations, let's simplify underneath that radical first. So -2 quantity squared is 4 plus, because it's -2 times √3, I can just square each piece of that term. So squaring the -2, I get back 4, times squaring the √3, I get back 3. So R is equal to 4 plus 12. So R is equal to the square root of 4 plus 12. So R is equal to the square root of 16. So we get R is equal to 4. So I know that my R value is 4. And now I just need to figure out what theta is. And so I can first figure out what my reference angle is. That's tangent inverse of the opposite side, which is -2√3 all over the adjacent side, which is -2. So that gives me +√3. So let's just think about it in the first quadrant. And so tangent of what angle gives us √3? Well, that is 60 degrees, which is pi thirds. And so I know my reference angle is equal to pi thirds. So my angle for that polar coordinate, I have to sweep out pi plus a pi thirds. And so my angle theta is going to equal 4 pi thirds. And so now we have our point here. Equivalent point in polar coordinates to the rectangular coordinate, -2 root 3 is 4, 4 pi thirds. So let's go in the opposite direction. Let's say that we are given a point in polar coordinates and we want to figure out what it is in rectangular coordinates. So let's just look at a generic case again. So this time, let's say that we're given a point. I'm just going to put this in here like this. And let's say we have some value theta, and I'm just going to keep it in the first quadrant, but it could fall someplace else. And we were given what R is. So this point right here, let's say, is R theta. So we could create a triangle and go in the opposite direction of what we were just doing. We want to find our X and our Y values now. And so we need to figure out what this Y value is. We need to figure out what this X value is. And we're given what R is, and we're given what theta is. Well, let's think about it. So if I wanted to find X, well, that's the adjacent side of theta, and we're given the hypotenuse. So you think to yourself, okay, what trigonometric functions use adjacent and the hypotenuse? So I know that that is my cosine function. And so I know that cosine of theta is equal to X over R. And so to solve for X there, I know that X is equal to, I can multiply both sides of my equation by R. So X is equal to R cosine theta. So similarly, we can do the same thing to figure out what Y is. And so we're trying to find the opposite side of our angle theta, and we know what our hypotenuse is, R. So which trigonometric function uses our opposite and our hypotenuse is sine. So we know that sine theta is equal to the opposite, which is Y, over hypotenuse, which is R. So if we multiply both sides by R here, we get what Y is. So we get Y is equal to R sine theta. So going from polar coordinates to rectangular coordinates, we can use that formula. That X is going to be R cosine theta, and the Y value of the rectangular coordinate is going to be R sine theta. So I think this is a great section because it's kind of going through a lot of what we had learned at the beginning of the semester. And it's great because it's kind of preparing us for getting ready for the final in about a little over a month. So we have an example here in polar coordinates. So we have the polar coordinate -3 and -3 pi fourths. So we want to rewrite this in terms of a rectangular coordinate. So I can just go in and I can plug this into these formulas that we just derived, or I can, if I don't remember that, I can do what we've done in the past. And so if I was going to plot the polar coordinate -3 pi fourths, -3, or -3 pi fourths. Well, starting at our polar axis, I would go clockwise, -3 pi-4, or clockwise 3 pi-4. So I see that we're going to fall into our third quadrant. For -3 pi-4 in the terminal side, but my R value is -3. And so since my R value is -3, I am actually going to be in my first quadrant. So I'm going to go up 3 units. And so I can now, and knowing that that is -3 pi-4, I can tell what my angle is going to be in that first quadrant. My angle is going to have to be pi-4. So now if I look at my triangle, I know what R is. And so I want to find my opposite side. So opposite and hypotenuse is sine. So I know that sine of pi-4 is equal to the opposite, which is y, all over R, which is 3. So y is going to equal 3 times sine pi-4. So 3 times, well, sine of pi-4, which you should know without a calculator, is √2/2. So I get my y value here is 3√2 all over 2. My x value, I would use cosine because I want the adjacent side. So I have cosine of pi-4 equals x over the hypotenuse, or R, which is 3. So x I know is 3 cosine of pi-4. Cosine of pi-4 is also √2/2. And so 3 times √2/2 is 3√2 all over 2. So our point here, equivalent, is 3√2/2 all over, comma, 3√2/2. Okay, so let's just show that we would have gotten the same thing if we had used this formula, because our values of R and theta are a little different without mapping this. And so I can see that x is equal to R, which in our case is -3, cosine of theta. But theta that was given to me was -3 pi-4. So I have -3. I have cosine of -3 pi-4. Well, I know cosine of -3 pi-4. I'm in the third quadrant. I know cosine is negative in that third quadrant. So I'm going to just put negative. And my reference angle is pi-4. So cosine of pi-4 again is √2/2. So cosine of -3 pi-4 is going to be -√2/2. Multiplying that by -3, negative times a negative is a positive, I get x is 3√2/2, which we just showed over here. And then our y value using this formula is R, which we were given -3 sine of theta. Theta we were given was -3 pi-4. So I'm in the third quadrant. I know my sine value is negative in the third quadrant, and then sine of my reference angle pi-4 is √2/2. You could also use the fact that cosine is an even function, so cosine of negative theta is equal to cosine theta. You can also use the fact that sine is an odd function, so sine of negative theta is equal to negative sine theta. So that's another way that you could look at these when you're doing them. So we got y is, again, 3√2/2, which is the same thing we got by just plotting things plotting our polar coordinate and working off our triangle. So looking at one more example, converting polar coordinates to rectangular coordinates. This example, we're given 2 2π3 is our polar coordinate. So let's first plot this. So going over 2π3, so we're going counterclockwise 2π3. That is going to get me to what would be in the second quadrant. I was looking at rectangular coordinates. My reference angle, if I went out here, I know is π3. And I know that my R value is equal to 2. So if I thought about it using my triangle, we know what this angle is in here, which is π3. So theta sub R is π3. And I know that I'm in the second quadrant. I know my R value is 2. I know cosine is, cosine is negative in that quadrant. So I know that X is equal to R to cosine of 2π3. I want to just use the formula. So X is equal to 2. So reference angle π3. I know cosine of π3 is 1/2. But again, I'm in the second quadrant, so it's going to be negative for cosine. So negative 1/2. So X is going to equal 2 times negative 1/2, which is negative 1. My Y value, use either the triangle or my formula, R sine theta. So Y is equal to R, which is 2 sine theta. Theta we were given was 2π3. I know my reference angle is π3, and I know that sine is positive in the second quadrant. So sine of π3 is the √3/2. So I have 2 times √3/2. So I get my Y value here. My 2's cancel in the numerator denominator, leaving me with just √3. So the equivalent rectangular coordinate would be -1 √3. Okay, so now we're going to jump into where we're given an equation. So an equation in rectangular coordinates, and we want to convert it to polar coordinates, or we're given an equation with polar coordinates, and we're a polar equation, and we want to rewrite it in terms of a rectangular equation. And so there's a couple things that you need to notice. So let's start with the rectangular coordinates. Well, again, we know that R is equal to, or R squared is equal to X squared plus Y squared. So we're looking for that. And we know that X is equal to R cosine theta, and Y is equal to R sine theta. So let's look at the following example where we're converting this equation from rectangular coordinates, and we want to rewrite it in terms of polar coordinates. So let's say that we have 2x squared plus 2y squared equals 3. 2x squared plus 2y squared is equal to 3. So I'm looking at for pieces that look similar to what I have above. And I noticed that I can factor out a 2 here. So if I factor out a 2 on the left-hand side of my equation, I have 2 times x squared plus y squared is equal to 3. But x squared plus y squared, that's the same thing as r squared. So let's replace that x squared plus y squared with r squared. So we get 2r squared is equal to 3. So we can leave it like that, or we could do some more manipulations. We could divide through by 2. So r squared is equal to 3/2. I could take the square root of both sides and I would get r is equal to plus or minus the square root of the fraction 3/2. As long as we rewrite this, our equation that is from rectangular coordinates, what has the x and y's, and we rewrite it, there's no more x and y's in there, and it's in terms of just r, or r and theta, or just theta. So let's look at another example. So let's say in here, we're given that we have 4x squared y equals 1. So 4x squared y is equal to 1. Okay, well, we know that from up here, x is equal to r cosine theta. So let's go in here. We have 4x quantity squared, but x is the same thing as r cosine theta times y. Well, y is r sine theta. So r sine theta times r sine theta. And this is equal to 1. So 4 times, if I square r cosine theta, I can write that as r squared cosine squared theta times r sine theta equals 1. So multiplication is commutative here. So I could rewrite the order as 4r squared times r cosine squared theta times sine theta equals 1. So I have 4r squared times r is r cubed cosine squared theta sine theta equals to 1. So we just saw a couple of examples from having an equation in rectangular form and rewriting it in polar form. And so let's go in the opposite direction where we're given an equation in polar form, and then we want to rewrite it in terms of a rectangular form. Okay, so our example here is r is equal to sine theta plus 1, and we want to rewrite this into rectangular coordinates. And so I pulled down again what we had written, that r squared equals x squared plus y squared, x is equal to r cosine theta, and y is equal to r sine theta. And so we kind of want to manipulate this equation to get what we have. And so I know that r sine theta, I can rewrite as y. So let's just look at this equation and let's multiply both sides by r so we can get an r in front of our sine theta. So it's an equation, so what we do on one side, we do on the other side. So we have here r times r, which is r squared, is equal to, let's distribute that r sine theta plus r. Well, r squared from above is equal to x squared plus y squared. So this r squared we can replace with x squared plus y squared is equal to r sine theta, but r sine theta is the same thing as y. So let's put y here, plus r. Well, r we can look at by looking at the square root of both sides. And so that would be the square root of x squared plus y squared. Okay, so now we just converted that into rectangular coordinates. So let's look at one more example, and then we're pretty much done with this section on polar coordinates. And so let's say that you're given r is equal to 3, all divided by the quantity 3 minus cosine theta. So let's start out with this problem by clearing our fraction. And so we can clear our fractions by multiplying both sides by our denominator of 3 minus cosine theta. So distributing our r into that parentheses 3 minus cosine theta, we're given 3r minus r cosine theta is equal to, well, the 3 minus cosine thetas cancel here, leaving us with just 3. So we know what r is. R is equal to the square root of x squared plus y squared. So we have 3 times the square root of x squared plus y squared minus, well, 3, and not 3, r cosine theta is just x, is equal to 3. So we just converted our equation in polar coordinates to an equation in rectangular coordinates. So hopefully that wasn't too bad for you and you understood what was going on. And that is the section on polar coordinates, which in our textbook is 10.1.